Thank you, gentlemen. Appreciate you both and for sharing your insights on getting on board. Again, if you got questions or thoughts in the meantime, while Chris from BluWave presents, go ahead and throw those in the chat box and we'll bring them around in a minute. I'd like to introduce Chris Galbraith from BluWave-ai, who's worked together with Katz to put together today's presentation. I'll turn it over to him. I'm going to make him the spotlight video here for you. So Chris is a project manager with BluWave, and I'll let him tell you about what they're working on in this space for the transit industry.
All right, sounds good. Thanks for the introduction, Rich. Just going to pull up my slides here. All right, yeah, so good afternoon, everyone. Thanks for your time today. As mentioned, I'm Chris Galbraith. I'm a product manager with BluWave-ai, and we're a cloud software company headquartered in Ottawa, Canada. So it's kind of cool today to be bringing one capital region together with another, which this webinar. So we specialize in renewable energy and electric vehicle management. And today what I'm going to do is take you through some of our solutions for electrifying fleets. Some of the ways we can use our cloud-based AI software to help out with some of the different challenges that are seen when switching over to electric vehicles. And yeah, we'll sort of address those common challenges. And this is really applicable to a number of different things, not just transit fleets in the cases that Theo and James were describing with their implementation of CATS, but more generally, we look at last mile delivery and institutional fleet settings to things like airport vehicles. So moving forward from there, I'll give you a brief introduction to our group and what we're all about. So as mentioned, we're based in Ottawa, Canada. Generally speaking, we're a software as a service company, and we have an artificial intelligence platform for renewable energy and electric vehicles. And broadly speaking, our goal is to try and squeeze more efficiency out of renewable energy and EV equipment that's being adopted everywhere right now. We were founded back in 2017. We've got a pretty healthy IP portfolio with 13 patents filed and 3 granted. And we claim to having the first ever automated artificial intelligence Canadian and Indian market AI dispatch. Generally, we're looking to enhance the efficiency of renewable energy hardware everywhere using our AI solution. So let's take a look in a little more detail at how that works. If you think about every year as being a set of a little over 100,000 blocks of 5 minutes, during every 5 minutes, there are a lot of different decisions made about how energy assets get managed all over the world. And if we can use our software to make those decisions in a systematic way and make them in a more optimal way, there's huge opportunity for efficiency to be gained, and that'll benefit everybody. So our system can work with a bunch of different types of energy resources, and it brings in data from a multitude of different sources automatically in order to make these intelligent decisions on the fly. In the case of EV fleets, we're looking down here at this bottom right-hand corner of the map, where our solution can help optimize things like the charging schedule within the constraints of the operating schedule of the business, which of course has to be maintained no matter what, as well as management of any local energy resources in order to help optimize the energy costs that are being paid for by the fleet operator. So focusing in on this set of use cases for electric fleets, the product we have is called the EV Fleet Orchestrator. This is an AI-based automatic management system for your chargers and your depot energy resources if you have them. So it provides automatic charger management. It does automatic prediction and optimization of your energy costs. So this includes both the energy you pull from the grid for charging and for running your garages and your depot, as well as any energy that you're able to generate locally. It does a whole picture integration of the charging within the context of the depot. So again, if you have anything like battery energy storage on site or other local distributed energy resources, DERs, that's all kind of folded in a coordinated fashion in order to do the best possible solution for when you charge, how fast you charge, how much you charge which vehicles. And it all adapts in real time. Since it's a flexible AI-based solution, it's able to respond to all the different stuff that can come up when you're managing a fast-paced organic system like a transit depot. So you're talking about different energy assets that may or may not be producing, may or may not be available from one moment to the next. Some of the contingencies that come up when you're running your bus fleet, you may have a bus breakdown, need maintenance unexpectedly. The system can adapt to all that kind of stuff in real time. So speaking a little more specifically to some of the challenges that you see when you go to electrify your fleet, as Theo and James were kind of speaking to a little bit, it's more than a question of just buying the buses, waiting for them to show up and going out to drive. There are challenges in integrating this stuff into your operation. It's not the same as running a diesel fleet anymore. So some of the things that can come up commonly You have to think about your energy costs and your emissions. Of course, switching to EVs, the goal is to reduce those GHG emissions to try and run a greener fleet. But that doesn't do you any good if the buses aren't actually being used and used as much as possible, right? You need to be taking the diesel vehicles off the road in order to realize that benefit in the electric buses. There's a question of energy cost and also any sort of market mechanisms or market participation that might be available in your region. So if you think about your set of electric buses as a big sort of battery or as the charging of those buses as a load that you can turn down at will, you can use that capacity in order to participate in demand response markets if that's available in the region. There's a question of the capital expenditure up front. So you're buying buses, you're buying chargers, you're paying for the grid upgrades. It's useful to ahead of time go through the exercise of optimizing all that, making sure you're not paying for more hardware than you need to actually run your optimizations, run your operations. And our system can help optimize that upfront decision-making process to understand, say, how much grid connection capacity you really need to have all your buses charged and ready to run in the morning. In addition to that, as I already mentioned, we're able to holistically manage everything that goes on with the electricity at the depot. So you're not just charging buses, you've got a building with HVAC and lights. You may or may not have local energy resources like natural gas gensets, rooftop solar, local battery storage. All that stuff needs to be coordinated if you want to squeeze the most efficiency possible. And the most cost savings possible out of your charging optimization scheme. So that's the set of challenges that need to be addressed if you're looking to be as efficient as possible with a large scale electric fleet rollout. Practically speaking, how do you approach this as an operator? How do you approach this as someone running a depot? You need to come up with a dispatch for when you're charging which buses, how fast, at what times, all that stuff, and that has to fit within your operating schedule as well. So you're taking in data from your transit schedule, you're taking in data about the EV state of charge when it rolls out to start the route, and also when it comes back at the end of the route. And if you have opportunity charging available on your routes, so en route charging is a common solution being deployed in a lot of cities. That also has to be rolled into the calculation as well to figure out, again, how much battery charge do you have when they come back, how much do they need when they go out for a given route, and therefore how much are we charging them and when while they're in the depot. In addition to that, you've got all of the depot energy needs, which also factors into the electricity you're drawing from the grid. And if you have any renewable energy that's local, that's great to have, but it introduces an additional degree of complication to the question of how to manage all of this. So our solution is really a set of software tools that pulls all this stuff together. So we have something called an edge node. This is a piece of software that lives in the cloud. It talks to all the different energy assets at your depot. So we'll look at your building meters. It'll speak to the chargers. It'll pull data from the buses where needed. It'll also integrate with your scheduling software in order to make sure it knows when the buses are due to be ready to go out on the road the next day. And this also can communicate with other entities. So if you're running more than one depot, the software can tie the operations together as well and deal with different facilities in a coordinated manner. It's also able to speak directly to some of the sources for, say, energy pricing information from the utility, as well as weather forecasts and other things that affect not only renewable energies, but these also can have an effect on your battery state of charge as well. It's probably not as much of a problem in your neck of the woods, but up here in Ottawa, we see some pretty cold winters, and that can have a serious effect on how much range you can get out of the battery over the course of the route. So all that together is our BluWave-ai EV Fleet Orchestrator. It's a software solution that ties all this data together and helps you produce a charge dispatch, which is optimized to get your EVs on the road as much as possible and to save you as much energy as possible, or energy costs as possible. Looking at a little bit more of a geographical layout for how this works. So again, it's a cloud solution. It can be accessed from a web-based dashboard wherever you need it. So you can have your operator in the back room with full visibility of all your depot energy systems. Here we're tying together a couple of different facilities. So there's a large depot on the left with some solar on the rooftop and battery storage, as well as some building loads that are integrated into the system and EV charging stations. On the right-hand side, we have a smaller garage that has EV charging only. And in the middle, we have a small station with opportunity charging en route. And these are all tied together with their own connection to the cloud, which then ties back into the grid. And that's also the source of the power for charging the majority of these vehicles. So the system is working individually with each of these depots, but bringing all that data back together to calculate how to manage them in an optimal fashion. Looking at a little bit more of a practical example, this is a graph from one of our dashboards, which is sort of showing the nuts and bolts of how the energy breakdown is handled by our system. So I'll walk you through what we're looking at here. The blue line is how much energy is being drawn from the grid over the course of a couple of days here. The yellow line is output from a rooftop solar installation. So on the left here, you can see we got a cloudy day. It's up and down a lot, and it's not at full capacity. On the right, we've got a pretty sunny day. It's a nice smooth curve of solar energy being generated. And the interesting part is this purple curve here. And this is actually the capacity of a battery that they have at the facility here. So you can see it's running the first day at pretty low values, down around 10%, goes up to 100% overnight, and then has a dip the following day. And fun fact about this, I don't know if there are any Bryan Adams fans in the audience, but this second dip here is actually a Bryan Adams concert at the facility that we manage. So he, last month, he kicked off a tour in Prince Edward Island, Canada. As luck would have it, we happened to manage the energy resources that were at the, it wasn't a bus depot, it was, in this case, it was an actual concert venue with where we managed all the energy resources. And we were able to time shift solar energy from the day before using that battery in order to run his concert on 100% solar power. So we were able to take energy from the previous day, pump it into the battery, and then when the concert went, we ran all the amps, all the lights, all that stuff was run using 100% solar energy on the day of. So that was a pretty cool application of technology. The principle here applies, right? If you have a high demand charging day, you can use our system in much the same manner to automatically shift renewable energy, cheap or even free renewable energy, or perhaps cheaper energy from the grid that's brought in at an opportune time to meet that demand. Quickly speaking to another practical example here, we're doing a fleet orchestrator installation with a large transit operation at one of the major Canadian cities. And they're actually planning to ramp up to 2,000 electric buses over the next 10 years. So it's going to be a pretty huge rollout. We're managing 9 depots for them. And there are a number of different advantages that we're delivering with the system for them. So we're working with their telemetry pulled from the buses and their back office software for scheduling. We're going to be predicting their building loads and fleet charging demand and controlling the chargers in a way that tries to minimize the energy prices that they're paying. And the way it works in some provinces here in Canada, there's some tricky energy pricing mechanisms to try to avoid that have to do with not contributing to the highest peaks that are produced over the course of the year. So we have to use our software to try to predict when are not just peak hours during the day, but over the course of the year, when are you likely to have a large peak event, and make sure that they're not charging during that. Of course, the most important thing is that we keep the vehicles running to schedule. So all these optimizations happen within the framework of the operating schedule of the fleet. And we're rolling in a bunch of different energy resources to be able to do this. So they have backup generators on site. They have battery energy storage systems on site. And they also have their depot loads, building lights, HVAC, all that stuff that has to be accounted for and how much they're drawing from the grid. And finally, I'll give one other sort of slightly different example of an implementation where we've been able to use this. So we worked with a taxi fleet that has a large number of electric vehicles on the road, I think up to a couple of hundred Teslas actually, not in North America. And by running our solution, it's possible to achieve a 15% reduction in fossil fuel miles. This is with more efficient charging strategies and better optimization. This results in an 8.3% cost savings. So that goes straight to their bottom line. And of course, a significant reduction in GHG emissions. And one of the other advantages that's not called out here is we were also able to bias their charging from fast charging down to slow charging for these vehicles. So rather than having the drivers charge in a hurry in an emergency situation where they're trying to get out and make it to a call, by planning ahead and by optimizing the charging schedule, we could have them rely more on slower charging, which is less harmful to the battery. They're actually going to see more lifespan out of those batteries by implementing this approach. All right, just kind of sum up some of the advantages of what our system's able to offer, both for fleet operators and for the utilities that have large fleets working under their jurisdiction. One of the main things is maximizing those EV miles. As I was speaking to Theo and James made the point, like the buses look pretty, but unless they're out driving, they're not reaching their full potential. So our solution is able to, especially as we scale and have more and more buses on the road and managing the charging gets more and more complicated, picking the routes, assessing whether a bus has enough range for a route. Our solution is able to help you kind of squeeze down those safety margins and really maximize how much you're using those assets that you've invested in. So yeah, maximize EV miles, minimize diesel miles while also maintaining your service schedule. We're able to minimize energy costs. This depends a little bit on, well, A, whether or not you have any renewables on site, and B, sort of what pricing mechanisms are built in your locale. And that's, of course, different internationally, state by state, province by province. We see that there's different stuff everywhere in terms of how energy is built. But yeah, depending on what mechanisms are available, there's more efficiency to be had by being smart about when you choose to charge. That's a common theme everywhere. We're able to reduce load at those peak demand periods, potentially reduce the upfront capex if there's efficiencies to be had in terms of your charger to vehicle ratio. So maybe you can get away with having fewer charging bays than you do vehicles in some situations, which then in turn allows you to reduce the size of the grid connection upgrade that's needed. And finally, you're able to centralize control of all these different systems, right? Like if you're buying chargers, you have software for the chargers. You may have separate telematics software for the buses. You have on-site energy resources that each come with their own control software. It's a lot to manage, and none of it's designed natively to talk to all the other stuff. So our system pulls all those pieces together, gives you a centralized dashboard view for what's going on, in addition to controlling everything in a coordinated manner. And then for utilities, while they're not the ones who are deploying this solution themselves, there are some other advantages there as well. It sort of mitigates the need for these large infrastructure upgrades in order to supply these facilities that are rolling out large amounts of charging all at once. It enables these depots potentially to participate in energy market programs, which is great. And it can also integrate with one of our other products, which is aimed at residential EVs. So there's potential there for great visibility for utilities if they have our EV Everywhere product deployed for residential charging management, as well as having depots and fleets on a solution from us for managing those commercial or municipal transit fleets. In terms of how we work, I'll just briefly note that we usually start with an offline study. So we'll pull data from a new deployment before we actually run our software live controlling assets. And we do that so that we can do kind of an offline background study and prove out, what can the system actually deliver once it's deployed live. So we model the chargers, we model the buses, we model all the different energy usage that's going to happen. And based on that, we can say ahead of time what efficiencies there are to be gained. And the nice thing here is we can also give you some comments on infrastructure that needs to be built out. So again, I was mentioning like how much capacity do you really need for the charging demand? That's something we can help with. And then from there, if the results look good, then we would move on to a live deployment where we're bringing in schedule information and actually actively managing the charging of the people. All right, and that's it for me. Thanks everybody for your attention. And please, if you have any questions or if you want to talk more, feel free to reach out to me at the email address on screen here, or you can speak to Richard Maxwell as well if you're not already talking to him, and his contact up here on the last slide as well. Thank you very much.
All right, well, thanks very much, Chris. And I have to congratulate you on having the first Brian Adams reference in a SWTA webinar, or probably any conference. You can work up a hip reference while we're sitting here today. I'd appreciate that. But,
well, he's one of our favorite Canadians. So,
Chris, people, often talk about electric vehicles in terms of the efficiency that the vehicle brings itself. But I mean, really thank you for the perspective of optimizing the electric use and just the overall depot setup and charging setup that, I've been around to a lot of transit systems and talked to folks managers who, played the hedge game on, diesel prices for decades and decades and were experts at this. This is the next step of doing that kind of management for the next, number of decades coming forward. So I appreciate your perspective on this. Feel free to keep sending questions in the chat box. I got another one for Chris is, you mentioned briefly for demand response, smaller vehicles for, paratransit operations, but also for rural communities. Tell us a little bit about how you all bring your approach to vehicles that aren't just operating on fixed routes all day long.
Yeah, so I mean, the solution I was speaking to today is it is more targeted at those like large deployments with fixed routes. So that's if it seems like it doesn't address the other conditions, that's you're right. It's not really designed for those sort of smaller units. To give you an analogy, though, we are working with some last mile delivery companies where the routes do vary, right? It's a smaller vehicle. The operations are the same day to day, but their routes are changing dynamically, and that's something our software is able to take in, right? Like if you're pushing a new schedule update every day, that's no problem. It can roll that into the calculations. In terms of smaller vehicles, still, we do have a separate product family that deals with residential charging. This is more of a challenge for utilities, right? A lot of our grids simply were not built to handle the kind of capacity that having EVs charging at every home is gonna bring within the next 5 or 10 years. So there's been some scrambling to make sure that they can handle it and sort of understand like what are the capacity upgrades, what are the transformer upgrades we need to roll out to address this demand. And the challenge there is that it's not kind of neatly controlled and predictable the way it would be for a fleet that's being electrified. So that's a different program, but we do have a solution there as well to work with utilities and get people to opt into a charging management program to try and take the edge off.
All right, thanks, Chris. Appreciate it. Chris, you talked about optimizing and monitoring the electric use. How does your system connect to maintenance folks at the agencies? What kind of access do they have to that system, and how do you train them up to use it?
Right, yeah, so our system, it's all dashboard based, right? So we have a fair degree of customizability in terms of how the information is presented to different departments when we're putting these solutions together. But yeah, the maintenance folks can have a view of the depot layout with chargers. They can have a view of the bus status as well. So we can do like a bus centric view, and instead of focusing on the depot layout. And yeah, you can see, you know, what route they were assigned to, where they're at, state of charge, and if we're not going to handle the maintenance calls, but our system has to be aware of those holes in the schedule where the bus is being looked after, the depot is not available for charging. So that's all integrated with the back office systems. But yeah, in terms of personnel having accounts, it's pretty simple. You just set up a profile and get them login access, and that's all pretty customizable. It's pretty portable. Being a cloud-based solution, we're flexible, and we implement with a new group in terms of, you know, who has access to it and who can see what. It's pretty easy to customize.
But with that, I want to thank Chris and for joining us here today, along with all of y'all. We'll have a few more of these sessions coming up over the fall. And just a heads up, our new SWTA website and member portal / database is going to be rolling out next month. And we'll also be doing our conference registration for our February conference through that. So stay tuned to the SWTA airwaves for news on that. But thanks for y'all joining again. Have a great rest of the week, and we'll talk to y'all real soon. Have a good one. Thanks, everybody.